Hello, this is Bryn LaRoche. I'm a Principal Solutions Architect at MongoDB, and today I'd like to talk to you about Realm IoT and the ability to have Realm software on an IoT device record temperature data and solve a cold chain management or a cold chain supply chain problem. So let's take a look at this. If you take a look at the plane, for example, and the ship and the truck and the store, each one of these has a Realm MQTT device installed. In other words, we have a small IoT device that has the Realm MQTT software installed on it. This can have one or more sensors that are deployed in the truck or within several cargo bays on a ship that actually collect data from those sensors. There's a Realm broker that actually runs there and Realm middleware software that allows you to synchronize that data to Realm Sync. Once that data comes into Realm Sync, we have functions, we have triggers, we have web pages that can display this information, webhooks that allow you to get that information, and then all the data is stored into MongoDB Atlas. This data is then replicated across different cloud providers, Azure, GCP, or AWS, and can be replicated across regions within those cloud providers. So it's highly replicated and highly available. The other thing that's very interesting is that we have the ability to auto-archive that data and take it from Elastic Block Store to Object Store so that you can actually archive that data within a day, 3 days, 7 days, 90 days, however much data you want to store, you can actually store online in Elastic Block Store and then move it to S3 buckets, but still be able to query that information. The actual updates are occurring on the live data on the MongoDB Atlas servers, but the S3 buckets are still available for things like data warehouse queries or historical queries against your IoT data. That gives you object store economics, which is an order of magnitude cheaper than Elastic Block Store. So let's take a look at a real demo of this in action. We're going to actually look at real devices. And as you can see, we have some emulated software here for Android devices that are actually taking a look at different data that's actually in the store, including Sugar Rush ice cream cone. We're actually looking at data for a particular store. This is store 161. It's called Brave Organics. This is a fictitious company with a new product called Sugar Rush ice cream cones. And they sell for about $10 a pop. The interesting thing about Sugar Rush ice cream is that once it hits a temperature of 65 degrees, it begins to sublimate. It begins to turn into a gas. And people, as they eat the ice cream, literally inhale the sugar fumes for a sugar rush. And as you can see, it's wildly popular. We have people wrapped around the building to come in to buy this. And we're having trouble keeping a supply up. The trick is to keep that supply at temperatures below 65 degrees. If it reaches 65, the canister of Sugar Rush ice cream will sublimate, turn into a gas, and the product will be destroyed. So we have a cold chain management problem that we have to solve. So let's take a look. As we sell things, we can actually see that we have Sugar Rush ice cream in this particular store. We are below the quantity. I'm going to go ahead and up this just for demonstration purposes to say we're up to 299. And then we're going to actually take that back down to say 201. And as I'm doing this, you'll actually see that this is synchronized on the mobile device. So whatever I put in here is actually set to that device. I'm actually going to go over here and I'm going to delete some of the messages from a previous demo so that we have a fresh, clean slate. And one of the things we'll do is once we get down to below the minimum quantity, which is set to 200, we're at the minimum quantity. We can see that it's set to 200 here. Everything is synchronized. I'm going to go ahead and reduce that one more. We're below the minimum quantity. So that has caused one of the triggers that we talked about in the Realm serverless application to actually fire. And that trigger has sent a voice message or a text message via Twilio to notify us that we have reached below the minimum quantity and we need to have some more ice cream delivered to store 161. So what we'll do is we'll take a look for the trucks in the nearby area. We'll search for this information and we actually see that we do have a truck nearby and we're going to actually have that truck deliver. You notice this red circle, and what this red circle is is a geofence. And MongoDB supports the ability to do geofencing both with our triggers and functions. We have the ability to do geospatial queries and index those queries for fast results. So this is a perfect use case. This entire web page that we're looking at is what we talked about being hosted in Realm serverless. So this is running serverless as well. I did not have to install on a server. It auto scales as more people use it, and all the functions and capabilities are there. So this is using the Leaflet API, and this is nothing more than an HTML page and JavaScript using the Realm JavaScript SDK. And so we're able to access the data inside the Atlas database and display it here. So let's go ahead and have this truck actually show up on site at the store. And as we do so, we'll update the truck's location, and then we'll see that it has in fact arrived at the store. We can see the store and the geofence. And so we should have received information that the Sugar Rush ice cream truck has arrived, and it has. So we need to check the back office to see what's going on and begin receiving. So it's here, the truck is here. Let's go to take a look at the truck. We're gonna deliver a canister. And so one of the things I'm gonna do is I'm going to actually open up the truck. And what we're seeing here is the truck. This is my cooler, and it actually has a Raspberry Pi. This has the Realm IoT software running on that Raspberry Pi. This is a wired sensor. It's a DHT11 that actually gets the temperature data from inside this cooler. And so I'm going to open the truck and begin my delivery of the ice cream to the store. And as I do so, I'm going to show you the DHT11 sensor. This sensor right here is what's actually getting the temperature. And you can actually see this temperature. If I hold it, you can see the temperature begin to rise from its current state. I'm going to put it up here for now. And then I'm going to call that attention to this. This is down here. And as we see the temperature rising, we can actually see it going up from 46 to 48 degrees. And the temperature is getting higher. So I'm delivering the Sugar Rush ice cream canister. I'm going to subtract a quantity off of this. You can see it's going up to 53 degrees. If this is on the truck driver's mobile device, he should be alerted that the temperature is rising, and he should be paying attention that he needs to do something quickly, because once it hits 65 degrees, he's going to lose all 69 canisters. Each canister is worth about $1,000. He's going to lose about $69,000 in a few seconds. But he's not paying attention for the purposes of this demo. And he's actually going into the store. He's actually reduced this number. Now we're going to the store, and we're going to actually increase the number. One canister is 100 scoops of ice cream. So we're going to, or 100 ice cream cones. So we're actually going to update the information here. And we're going to update this to 299. And everything is good, but we're getting dangerously close on that particular thing. So as you can see, I'm going to go ahead and hold it for a second. And then, oh, well, right there, it just hit. And we just noticed, if you notice that it did hit, oh no, not quite. It's 65 humidity, I'm sorry. We're at 64.4. I'm just going to leave it here and hold it real quick for a second. And we'll just have it bump up to 65. So we went to 66. And when this happened, a trigger fired. And if I take a look at the truck data again, let's go back to the truck. You'll notice that, here we go, here's the truck. You can see that it's boiled, and it gives the date and time that it's boiled. And so we know exactly when this boiled. And this tells us the information. If we had actually gone on a plane or overseas, or so for example, if I had gone to a ship, let's take a look at a ship. It's out here at the sea, and it leaves port, and we lose internet connection to it. Then as the ice cream canisters and the cargoes on that ship, if it goes out to sea and spoils, when it comes back, all that data is stored in the MQTT broker. It will be synchronized with Realm, and we'll get every second of data, not lose a beat, and we'll know exactly at what time that product spoiled. That's the nutshell of this. This is a real demo with real software, and you can see the mobile devices and everything being synchronized. I'm going to go ahead and show you the architecture behind this. And go Go ahead and maximize this. You can actually see that what's going on here is you have a variety of sensors, both wireless and wired, that are connected to a Raspberry Pi or an ESP8826, various different IoT devices that you can buy, install the software onto. We actually have the Realm MQTT broker and middleware running in a Docker container, as well as the MQTT client and the Raspberry on the Raspberry Pi. We also have a container called an updater. And what that does is it looks to Docker Hub. So as you push new images, you can actually update your devices. So if you have 90,000 different devices, imagine having to manually update the software on each one of those devices. We've come up with a way that you can actually push that data down to all your devices, have the software updated in real time, push configuration changes, and maybe even push the changes to a particular device so that you can have certain devices with different versions and configurations of software. As this data is gathered from the sensors, we can actually see it going through the Realm serverless, where we have Realm Sync to the mobile devices. We have functions and triggers that take advantage of that data. Like when we hit the temperature, there's a trigger that fired off, called a function, notified people that this action needed to be taken. The web page is here, serverless. It allows us to take a look at that. And we have webhooks for REST API calls and for GraphQL, for example, being able to come in and query this data. Again, cross-cloud replication. So that's it for Realm IoT. There is a GitHub with all of the information on how to set this up on your own. If you want to get started, all the software and all the bits and bytes and how to configure everything is actually specified out here. It would take probably a couple hours to set everything up, and you can actually get started with this. This GitHub link will be provided in the video as well at the link at the bottom. Thank you so much. Thank you for your time. I hope to hear from you soon.